Okay, I have a question.
Okay, and like the sound, like say that this would not be a
Right.
so she needs to have like either spiral bound. It could be a composition one. That's fine also.
What's so bad about this?
That's not what I asked for.
Okay, but you. Never mind. Okay. I'm gonna know.
There you go. That's what I want to hear. Fantastic. Okay, so today the plans for today are to finish yesterday's lecture on introduction to geometry. But before we do that, just I know it's the first week and we're getting used to things. I want to go over some things we went over yesterday, just even quicker than we did yesterday, and then move on to finish the lecture. Okay. So as you can see on the board, what is on the board presently? What are we looking at? Yes, this is the E-class. And of the most urgency, if you have not done so, is to fill out the syllabus receipt form. Yesterday, as of yesterday, we had around 50 kids at this time that had turned it in. Today, as of this morning, we were around like 82. Which sounds like an improvement, sure, but when you consider I have somewhere in the neighborhood of 150 students, that means that nearly half of them still haven't done it. So tonight's basically the last night that you have. Because come tomorrow morning, what am I going? I'm going to go hunting for F's. Yeah, I'm looking for the F's. Tomorrow morning, I'm going to go look for who has not done it, and those people are going to get the F's, and that F is going to stay there. You will eventually still have to fill it out. You're going to get it turned in. It's just not going to be for any credit. So it's in your best interest to get it done ASAP if you have not done so. Just get on the E-class, get that done. Okay. Then those of you that do have it ready by tomorrow morning, then we'll shift over to phase 2, which is to get that information put into Remind 101. And then once your parents sign up, then I'll give you the A. Okay. The next thing I would draw your attention to, which I want to get in the habit of doing at the beginning of each class, is when you click on the content for that week, here on week 1, to look at homework help. So period 4 homework help. Most weeks will only have one thread here, but this week we have 2 assignments, so there's 2 threads, and I don't see any replies. If there were any replies, then I would go over those problems now. How would we reply, or why would we reply? Well, if you're working on a problem that you're stuck on, you have no idea what to do, take a screenshot of that problem, pick the appropriate thread. In this case, if it's operations with fractions, you would click on that one. If it's the week 1 assignment, which is what we started working on yesterday, you would click on that one and you would reply. When you reply, depending on what device you're using, you would either paste the screenshot, or on some of them you might have to upload the screenshot. If you need help with your particular device, I'll deal with that on a one-on-one basis. My posted office hours are in the morning. This morning I had somebody drop by for help with Khan Academy. You know, and look, just to show you, I'll do my part. The student last night emailed me because they were trying to get on the assignment, and they had a legitimate concern. It ended up that she was doing everything right, and it was an issue with the site. Khan Academy, in my experience, doesn't have a lot of site problems, but you know, her assignments weren't showing up, and she emailed me. I emailed her back immediately, and it was back and forth, back and forth. I wasn't able to troubleshoot it by email, so she came in this morning, and it got fixed. So if you have any issues with anything with E-class, anything with Khan Academy, anything that's individual to you, probably the best time to deal with that would be before school. If you come after school, I may or may not be able to help you. Like today, I have a meeting after school. I have a couple kids that say that they're going to be here right when the bell rings. I'll try to help them out. But if the best time overall is before school. Hopefully, I'm hoping you take advantage of this. Because now this is it. Hey, I'm stuck on a problem. I need help on it. I'll do it for you step by step. All I ask is that you post me here. Then before we move on to the notes, the last thing on E-class I want to point out to you is if you're also under week 1. Yesterday I showed you this lectures and notes section. How many of you went home last night and wrote in all the notes as I suggested, just to have them already in there? Crickets. Well, not only are the notes still there, for you to write in, and I still suggest that you do them ahead of time. You have new notes tomorrow. But what else do you see there that wasn't there before? Yeah, that's a video of yesterday's class. And it was actually this period that made the cut. Yeah, yay. Yeah, you haven't seen my fifth period, but they're not putting up too big of a challenge, put it that way. But yeah, I think more as of now, more days than not, it's gonna be this class is the one that gets posted. So if you're here and you want to go back and listen to something again, it's there for you. If you're absent and you want to go listen to something, it's there for you. Even look, the student yesterday was very proactive. But when I was having trouble with Khan Academy, she even went over that part of class where I was describing Khan Academy just to make sure that she was doing everything right. I cannot blame her. We couldn't get it fixed, but she really did everything in her power to get it fixed, and we got it fixed this morning. Any questions on any of these things? Yes.
When I go on Khan Academy at home, when I click on the link, and I do a problem like 7 of them, then it goes down to another one. But is that the next link?
Yeah, I would never click. When you finish doing one of the exercises, and it gives you that summary page that gives you the score, sometimes it's going to say either next video or next assignment. I would not click that because I just don't trust it. They make revisions each year to their site. Maybe it's taking you to the next one that your teacher assigns, but in the past I've had problems that kids click that and they just go click next, and it's taking you to where they want you to go next, not necessarily where I want you to go next. So the safest thing would be each time you finish one, go back to that main page, look for the next one you want to work on, and click start on that again. Okay. Any other questions? All right, so then let's go back to the notes. Did I get this page covered? When we talked about the symbols for array and everything? Yes, no, blink once for yes. Did we get this covered?
No. We stopped where it says array.
Oh wait, no, not that. I'm sorry, here. That one right there.
That's where we stopped at.
But I covered that one.
Yeah.
Okay, all right. So then let's go to here.
Oh, yeah. They're pretty.
Okay, so continuing with our introduction to geometry, we get into an angle, and the textbook definition of an angle are two rays that meet at a common endpoint. So in order to know what an angle is, you need to know what a ray is. So what's a ray? What did we talk about yesterday was a ray?
Sorry guys. Doesn't it have an arrow?
Okay, one arrow, sure.
But doesn't it have 2 points and then it could have a arrow? But can it have 2 points and an arrow?
It's part of a line. Okay, it falls under the branch of lines. Part of a line, but as opposed to a line that goes forever in 2 directions, it goes forever in 1 direction, meaning it's going to have 1 arrow and 1 endpoint. So if you get that endpoint and you share that endpoint with another ray, what's created is an angle. Okay, so that's the textbook definition. But look, I mean, an angle can be created if you meet up 2 segments, because segments also have endpoints. An angle can be created if 2 lines intersect. Technically, a ray is part of a line. So, but if you look at a textbook, that's the textbook definition of an angle. There's 2 rays that meet at a common endpoint. So those rays, the rays themselves, how many rays are there? In an angle, 2. We call those the sides of the angle. And that common endpoint is known as the vertex. Yeah, if you can't see this, well, number one, I still haven't given a seating charge, so it might be a good idea when you get here more, see towards the front. Uh, this program I'm still like a little iffy on, like as far as how to zoom in. I think there is a way to zoom in, but it's a little bit buggy. So remember that you also have access to this online, and I still strongly recommend you have this already in the notebook before. This says vertex A, the sides are raised. Let me see if I can zoom in. I did it one time. I was able to zoom in once, but
I don't know about this program.
the program that comes with the smart boards to me is better than the Promethean. See if I can. I'm just trying to zoom in and then I'll put it back up. No, it's not even letting me zoom here.
Yeah, that seems odd. There seems like there would have to be a way for you to turn that.
I just remember like I even had to do a Google search for it. Let me see if this works. Yeah, it's not gonna let me zoom. Sorry about that. Okay, so can you see what's if a vertex is a common endpoint, it physically is a point. What's the vertex on this diagram here? What point is that meeting point? A, yeah. What are B and C? Those are the through points that the rays go through. So we have this angle has a side AB. The A would have to go first because when you're naming a ray, the endpoint goes first. On the bottom would be side AC. As you saw on the last page, that was already part of your notes. We talked about how to name rays with the arrow. One arrow. That's how you name a ray. Hopefully we have an activity at the end today that we can get to that soon. So how do you name an angle? Okay, the first thing you have to be aware of is the symbol. This kind of like, it looks almost like a Lexus emblem. It's like kind of like a slanted L. That's the symbol for angle. We talked about some symbols yesterday, like, let's see if I can write this. What's the symbol for a line? Use your words. What's the symbol for a line? If I wanted to name a line. It's like a horizontal line or dash. The key is you have two arrows and you need 2 points. So like we had lines, A, B, for instance, if we had a line. What's the symbol for a array? 1 arrow. Just making sure that the arrow has to be above the through point. What's another symbol we learned yesterday? A segment. A segment is just that horizontal line with no arrows. What's the symbol for an angle? It's going to be kind of like that slanted L. Now, if there is only one angle at a vertex, like there is here, then it is possible to name that angle by just the vertex. That's why what's one possible name for this angle? Angle A. seldom will you see a vertex that contains only one angle. So you're hardly never, you're not going to be able to name angles just by one letter very often. We're never going to name angles by two letters, by 2 points. But sometimes you can name it with one. If an angle has a number, which is hard to see here, but this one does, if there's a 4, you can always name it. But again, that's not going to be very common. You're not going to always see numbers there. And where you got to be careful, like when we get into triangles and stuff, a lot of times that number that's going to be there is going to be a measurement. What do we measure angles in? What unit do we measure angles in? Degrees. In degrees, yeah, in degrees. You ever get into like an algebra 2 class, then you'll get into radians. It's another unit measure for angles. But here we're going to measure in degrees. But then if that were the case, you would see a degree symbol. This doesn't have a degree symbol, so the reason that 4 is there, that's for a name. Now, the much more common way to name angles are with 3 points. Okay? Now, the only rule is that if you're going to use 3 points, the vertex has to be in the middle. What 3 points do you see there? What 3 points are being displayed on this angle? A, B, and C, right? So you can name this BAC or CAB. Either one is fine. What do they both have in common?
The what?
What do both of these names, the way I named these, what do they both have in common? They're not the same. What do they both have in common? What about the A? There you go. They both have a vertex in.
So can we name that angle CBA?
No.
No.
Vertex has to be in the middle. So here we go with now types of angles. We just mentioned that angles can get measured in a unit known as degrees. Depending on what that degree measure is, you can give an angle a type. You can categorize it. I believe we've heard of these before. If I ask you what a right angle is, can anybody tell me what a right angle is? Wait, Jamal. It's an angle that measures exactly 90 degrees. Okay? Does anybody know what another word? We'll talk about it on the next slide. I think it shows up. But another word is for a when two lines or two rays or two segments meet at 90 degrees. And actually, you should, because I believe this is part of Algebra 1. No? You want a clue? It starts with P and ends with perpendicular. Perpendicular, good, yeah. When two lines meet at 90 degrees, another word for that would be that the lines are perpendicular. The angle is a right angle, but the lines would be perpendicular. How about an acute angle? Yeah, it measures less than 90 degrees. How about an obtuse angle?
More than 90 degrees, but less than 100.
Yeah, and most of the time you get away with it, and it's a little bit of a lazy, like it's one of those things where like, okay, it's an okay answer, but you can answer better when people say, oh, it's greater than 90. Okay, fine, it's greater than 90, but if you want to be more specific, it also has to be less than 180. Now, one thing that's not up here, but if you had the notes already written down, it'd be easy because all the notes are written. Now I just said something that sounds interesting and you write it down. One thing that's not here is what happens if an angle measures exactly 180 degrees. That also has a name. Straight angle. Straight angle. What does it look like?
A line.
A line, yeah. It even has another name. I don't think you would know this one, but does anybody know another name for it's 2 words. I asked what a 180 degree angle is. She correctly said a straight angle. That is the name. It's a straight angle. I asked what it looks like. It looks like a line. Okay, but there's another terminology that could be used. If an angle is made up of rays, 2 rays, and 180 degrees are going away from each other, opposite rays. If you ever see something called opposite rays, they're talking about a line. Talking about a 180 degree angle. Okay, congruent angles. We talked about the word congruent yesterday. What does the word congruent mean? Equal. You hear the word congruent, equal, congruent, equal, congruent, equal, congruent, equal. Strangely enough, what does an equal sign look like? Yeah, it's like two little hashes, like a horizontal. Congruent also has a symbol. This is like an equal symbol, an equal sign. Stick a little mustache on top of that, and it's congruent. That's what you see there. So in this diagram that's being shown, angle NMP, notice how the M is in the middle, is congruent to angle, notice the angle symbol, QMR, with the M in the middle as well. Coincidentally, what do those two angles happen to measure? Because they do happen to give you the angle measure. I know it's hard to see, it's a little bit small. I can't zoom in, but what do those two angles happen to measure? 25. It's smaller, but they're both 25 degrees. Now, part of geometry is learning how to Did you have any leftovers? Yeah, these are the leftovers
Yes.
right here. Okay, perfect.
And there's all the notions.
So
Oh, and then Luna, she will get her notebook.
we have to learn how to mark diagrams. Like one of the things we talked about yesterday was being able to mark segments. Like we'll eventually get to triangles, right? So let's say I have a triangle, right? How many sides does the triangle have? 3, and each one of those sides happens to be a line segment because it begins and ends, right? If I wanted to say that two sides here, that two of the segments were the same, the way that you would mark that diagram is by putting a slash on the two that are the same. Just a fun bonus question. Anybody know what that's called? When you have a triangle with two sides that are the same?
What's the type of triangle?
Yeah, not that you have to know it. It's just I'm just throwing it out there so you. A triangle that has two sides that are congruent. Starts with an I. I saw something. So now the reason why I bring that up is because not because we're working on triangles, not even because we're working on congruent sides, but we are focusing on the word congruent and symbols. And if you look at this diagram, it's hard to see. I realize that, but they have these arcs here. Those arcs mean congruent. So even if they didn't write the 25 on each of those angles, you would still know that they were congruent because of those arcs. It depends on which book you get it from. Okay, I've seen books use different types of symbols, but if they were to also get those arcs and put a slash through it, that would also mean congruent. If they were to put like 2 slashes through it, it's hard to see, but 2 slashes through it, that would also mean that those are congruent. If the book that we're using decides to just use arcs, like I guess that's the book that I got this diagram from, they could also use multiple arcs in there. I stuck like a second arc and a second arc. As long as they match, that means that they're congruent. 1 arc with 1 arc, 2 arcs with 2 arcs, 3 arcs with 3 arcs. Any questions there? Okay, yesterday we talked about the word bisect. What does the word bisect mean?
Break the word apart.
Bisect.
I don't know, and I'm 2 or something.
Cut in 2, not just cut in 2, cut into 2 equal parts. Bisect means cut in half. Okay, yesterday we used it in the context of line segments. Because a line segment has a beginning and an end, what type of point cuts a line segment in half? A midpoint, yeah. You can have a point in the middle, and that midpoint would bisect a segment. Well, an angle can also be bisected. It can be cut in half. In this case, by a ray. So an angle bisector would be a ray that divides one angle into 2 congruent angles. I could go back up here to this diagram up on the top. Ooh. this is just hand drawn, so pardon the crudity here, but if I were to draw a ray, here, somebody give me a name for the ray that I just drew. Give me a name for that ray. AD. AD. The A would have to come first because that's the endpoint. So AD. And then if I were to add to that diagram, like an arc and an arc, what I'm telling the person looking at that diagram is that this new angle that's created, or these two new angles that are created, let's see if we can give these names, Luna. What would I call that first angle there I just highlighted in green? BAD, good, bad, yes. And what would that angle BAD be congruent to? Well, what's the other angle called? DAC, but I say, Luna, you're wrong. That's not DAC, that's CAD. Doesn't matter. Very good.
You guys really make sure you understand like the congruent markings, because you might get a problem or something, and it might not say necessarily in words that those two angles are congruent, but you have to know what those mean, that they are congruent. Does that make sense?
That's like a different language. Understanding the symbols. Okay. Oh no, please tell me I can zoom in on this.
An arrow on the top corner that you can go.
I really wanted you to be able to see this. Okay. Whoa, too much.
Oh, it did it. You found it.
Yeah, it did it, but it did too much.
That's what I'm looking at your
Wow, this is way harder than it needs to be, but okay. Okay, so now, the reason why I included this page, what I really like here, are not just the examples, because you've already seen examples of these, but I like this because it provides counter examples, meaning what's not, like that we can, the first one, a right angle, right? We talked about what a right angle is, which is an angle that measures exactly 90 degrees. But now this is going to also show us some examples of what a right angle is not. So then I could ask you, well, then why? These you can look at on your own. But look, more symbols. More symbols. What does this little box mean? Yeah. So here they actually tell you 90 degrees, but a box also means 90 degrees. Here we see an example of what type of lines? What word did we use? I said it earlier. Perpendicular. Good, Harvey. Good, perpendicular. But again, what I like the most about this, and I think it has the most profound effect, are these, the counter examples, okay, the non-examples. Here, the 46-degree angle, why is that not a right angle? It's a cube. Yeah, sure. The 105-degree angle, why is that not a right angle? It's obtuse, yeah, sure. Acute angle, we talked about. Acute angles measure less than 90. And here on the left, you see some examples. All of these are acute angles, but these on the right are not. So why is this one, this first one here, why is that one not? It's obtuse. How about this one here? Right. That one is right, good. And this one here? Yeah, it's obtuse. Wait, but that looks right to me, but how do we know it's not right? 91 degrees. Yeah, 91. It's obtuse. Good. Okay, obtuse angles, we talked about that before. Let's look at the graphic. On the left, we see all examples of obtuse angles. But on the right, we don't see, well, the 38, why is that not? 38 degrees, why is that not? That's acute, good. 89?
That's acute.
Also acute, yes. And then the one on the top is right because of the box. All right. This is gonna help you with the Khan Academy assignment. Complementary angles is the first time we see this. Complementary angles are a pair. What does the word pair mean? Two. So you can only have two angles. Exactly two angles that when you combine them, their sum. What does the word sum mean?
Like equals.
No. Sum.
Oh.
How do you find this to
Add together.
That's the word. Add. Yeah. If you look in a textbook, it will say that the sum is the result of addition, and they incorporate that word equal in there. But more important is the add part. Okay. So two angles that add up to 90 degrees. Okay. Here are examples on the left of complementary angles. Now we don't have a protractor, which is an instrument that we use to add. But if we did, and we measured this angle 1 and angle 2 here, it's not 1 plus 2, what? Come on. They tell you, so that you don't have to use a protractor. But if we did, if we'd add them up, if they add up to 90, that's complementary. Okay. Over here, 3 and 4, they don't tell us what 3 and 4 add up to, but how do we know that they add up to 90? Well, on the other side, yeah, on the other side, if this is 90, what did I tell you a straight line adds up to measure-wise? 180. Yeah, 180. So if I get 180 degrees and I use up 90 on one side, what does the other side have to add up to? 90. Do they tell me specifically how many degrees are in angle 3 and how many degrees are in angle 4? No, but I don't care because I know that together they add up to 90. Why are these two not complementary? They add up to 92. Why are 3 and 4 not complementary? What do they add up to? 180. They make a straight line, yeah. Which is also going to have a name. Anybody know what that name is before we get to that? No, it does not start with a C, but it does sound like complementary, but it doesn't start with a C. Supplementary. Supplementary. And with 1 and 2, it's hard to see why, but if you had a protractor and you added them together, it would not. It looks like it wouldn't even get to 90. They'd be less than 90 combined. Supplementary, if you really wanted me to pick a side or argue one way or the other, I'd argue that I don't know if they're more important, but I think they're going to be more frequent. Okay, supplementary angles show up more throughout the course than complementary does. What does supplementary mean? We're still adding, but now instead of adding up to 90, add up to 180. If two angles add up to make a straight line, then those two angles are supplementary. Here, 1 and 2 add up to make a straight line. Now, these are actually what are also called adjacent angles. They share a common endpoint. They're next to each other. In this case, not only are those supplementary, that's also what's referred to as a linear pair. Every linear pair is supplementary, but not every set of supplementary angles form a linear pair. These two angles here are supplementary because they tell us that they are. They tell us that if we were to add these, we would get to 180, but they don't share a common endpoint. They don't share a common vertex. Here, this is the vertex for 3, this is the vertex for 4. They're not touching each other. They're not right next to you. They're not on top of each other. But they are supplementary. What are they not? If they're not adjacent, you're right, they're not adjacent, but if they're not adjacent, that means that they're not coming up now. A linear pair. Okay. Now let's look again at the counter examples. Wait, but Mr. Romero, look, all 3 of these angles give me 180 degrees. But what's wrong there?
A pair.
Yeah, they're not a pair. How many angles do you see there? 3, yeah. Here we don't have a protractor, but if we would, it looks like those would add up to more than 180. Vertical angles. Okay, this is new terminology. Vertical angles. If two lines were to cross each other, how many angles are created here? How many angles are there in total? 4. Yeah. 4. 1, 2, 3, 4. Angles that are across from each other are vertical. We actually already said the name of the angles that are next to each other. So if I were to ask you what the vertical angles are here, what angles are across from each other? And in the example I just drew.
1, 3.
1 and 3.
2, 4.
And 2 and 4. Just for fun, what do we call angles that are next to each other? That you heard me say on the last example? Adjacent. There's actually 4 pairs of adjacent angles here. What angles here would be considered to be adjacent?
1, 4.
1 and 4.
3, 2.
2 and 3. 3 and 4.
1,
And 1 and 2. Yeah. Okay, in this case, adjacent angles would form a linear pair. They would be supplementary. Vertical angles, I guess it doesn't say it up here, but eventually what we're going to learn about vertical angles is that they are congruent. What does congruent mean? Equal. They're equal. Yeah, they're going to be equal. So you can look at some examples of angles that they tell you are vertical. Here, the non-examples I like looking at. Why are 1 and 2 not vertical? They're next to each other, meaning that they are adjacent. Yeah. 3 and 4 you haven't learned yet, but eventually we'll learn. Those are what are called alternate interior angles. They're at 2 different intersections. 3 is down here at this intersection. 4 is up here. In order to be vertical, they have to be part of the same intersection. 5 and 6 look like they're vertical, but the problem is that both of these lines are broken. They're not straight lines that are meeting through at one common intersection. 7 and 8 also looks like they're vertical, but this line is straight. This line obviously isn't. It doesn't go through, it bounces off. So 7 and 8 are not vertical. Who knows? Maybe it would end up, if you were to measure them, they'd be congruent, but you don't know for sure. And 9 and 10, it's because they don't share that common vertex. They don't touch. They look like they would be vertical, but they're not. Linear pair, we talked about what are linear pairs. Every linear pair is not adjacent. Every linear pair is starts with S, ends with supplementary. Supplementary, but not every supplementary angle forms a linear pair. All a linear pair is supplementary angles, angles that add up to 180, but that also share a common vertex. I got a little 10-minute warning going thing on my watch, so I know when there's 10 minutes left. So I want to, I would normally go over the counter examples, but I'll let you go over those on your own. What I wanted to get to was this page, which this is a department page, which are good to go over because I have a feeling that the quizzes would most resemble this. So, in instances where we have more time and I run out of these and I don't have any more examples to do, then we'll do the Khan Academy ones. But let's do as many of these as we can. For each of these, we're going to sketch it and then name it. Give the notation for it. So a point. How would I sketch a point? What does a point look like? Looks like a dot. And then what would you put on the sketch? Because you have to label the sketch. Capital letter. It has to be capitalized. How would you name it? Just with the capital letter. You might write the word point in front, but really just write the capital letter. Okay, a line. How do we sketch a line? What do we say? It has to have the 2 arrows. But on the sketch, you'd want to at least write 2 points. How many points make up a line? An infinite amount. I can keep on writing points there. But when it comes time to name, for the notation, to name a line, you still write the 2 arrows, but you just pick any 2 points. Is that the only way I could name that line? What else could I name it? VA, yeah, the way I drew, you can also name it VA. Okay, a plane we talked about, it's a point that goes in infinite in all directions. Space we didn't talk about, but I don't see that coming up. Collinear, what do we say that collinear stands for? Collinear means? Very good, 2 or more points on the same line. So instead of drawing a sketch, I'll just do one of these and refer you up there. That is, A and B are collinear on the sketch up there. Okay, coplanar means lie on the same plane. Did we talk about I think we did. Any 2 points have to be collinear, and that's why this shows up on Khan Academy. Because, I've seen it before on Khan Academy. I don't really like the way they word it. It's a little bit confusing, right? Because you're not going to actually see the line. But when they ask you about they're going to say, hey, are these 2 points collinear? The answer is always going to be yes. Because if it's 2 points, you can, even if you don't see the line, you could always draw the line technically if you wanted to. Okay? How many points have to be coplanar? Like, how many points can I always draw a plane through if I wanted to? If 2 points have to be collinear, how many points have to be coplanar? Same plane. 3, yeah, 3 points. But we're not going to draw anything there. An endpoint is a point at the end of a line. Okay, for that, like, we'll just skip here to ray, and we'll draw a ray. Here, let's change things up. What's the endpoint there of that ray that I just drew? B. B, yeah. So like B would be the endpoint there. A line segment, how do we draw? 2 endpoints, good. How do you name okay, fine, we'll leave it like that. Even better. Here I picked an A and a D. So how would I name it? A, D. You don't, when you're naming it, you don't draw the little dots. Is that the only way I can name a line segment? No, you can change the order. DA would work as well. But like here with array, now when I go to name it, here I'm going to name this BA. Can I also name this AB? With array, you cannot change the order. Okay, an intersection is a point or set of points where 2 or more lines cross each other. Okay, we already drew an intersection, and really I don't know what they mean by naming an intersection. I guess they would mean the point where they cross at. I guess here, if you want to find your notes, I would focus on that terminology there. What is an intersection? It's a point. So if I were to draw like an intersection here, and I put an A in the middle, what's the intersection there? That intersection would be A, point A. What's a vertex? What's a vertex? The common endpoint of an angle. So if I were to draw this angle, okay, let's use different letters just to. What's the vertex there? E. Parallel lines. Okay, we haven't talked about that. We talked about perpendicular, but how about parallel lines? Lines that never intersect. They're lines that go in the same direction infinitely. Here, this gives us a chance for symbols. Okay, how do we, let's say that this line up here was AB, and this line down here was CD. It's hard to draw with, so imagine that the points are there. What's the symbol for parallel lines? Depends on the book. Some books do them completely vertical, some books do them diagonally, but like that. So if I wanted to say that these lines were parallel, I would say line AB is parallel to line CD. Perpendicular, what do we say perpendicular meant? Perpendicular means? No. 2 lines that meet at 90 degrees. So if I drew a sketch, I put the box for 90 degrees. I have to put arrows because they're lines. Let's call this A, B, C. It's just hard to draw the point, and let's put E in the middle. Let's put like there's an E there. Now, when you name a line, how many points do you use? No, how many points do you use to name a line? Just 2, right? The symbol for perpendicular is going to be an upside down T. So even though you see a bunch of points here, I would just use two of them. I would say like line BD is perpendicular to line AC. An angle we talked about, just look for the angle. You can look up here. How do you name an angle here? We'll leave it at that. How do you name an angle? What's the most common way of naming an angle? Besides the symbol, which I drew for you, how many points? 3. You need 3. You need 3, and the vertex has to be in the middle. So looking at this angle that I drew up here, what was the vertex? E. That has to go in the middle. And then F and G. Here's what I'll do. Tomorrow, all that we had on was translations. That's all that was on the menu for tomorrow. That's kind of short. So I'll finish this first, and then we'll move on to translation. This is all we got. Yes, everything is here.
Yeah, week one, thing, right?
Yeah.
All the things are due, or Sunday or what?
Sunday, 11:59 p.m.